Welcome to All This Math. This is Professor Parker, and I want to give a shout out to Coppin State University, historically black college university located in Baltimore, Maryland, right? And I also want to give a shout out to collegiatelux.com, where I got this sweatshirt from. That's Collegiate Lux, collegiate, and then luxe.com. They got a lot of HBCU apparel on there, so go check them out. All right, so also, if you haven't subscribed to the YouTube channel yet, what you waiting for? Go ahead and subscribe to the channel. Also turn on the post notifications. Also like the video. Also share the video. I know I'm asking for a lot, right? But it's worth it though, because we're trying to teach math in the black community. That's what we're trying to do, right? So here we're going to get into some algebra. All right. I know a lot of people talk about, they're never going to need algebra. They don't need algebra. They need to, get rid of algebra and replace it with personal finance coursework. The two are not mutually exclusive, right? In order to teach personal finance, in order to teach economics, in order to teach corporate finance, you need algebra. You have to use algebra as a tool within those areas. So I want us to understand that the two are not mutually exclusive. So maybe what we should be advocating for is that in the mathematics courses, in the mathematics classrooms, that there are applications of algebra that are more directed toward areas such as personal finance, economics, real estate investment, stock market, cryptocurrency, all these other types of things that, we believe to be life skills that our young people need, right? But to say, get rid of algebra, you can't get rid of algebra because there is no personal finance. How are you going to calculate ROI? How are you going to calculate ROI on an investment? That's an algebraic equation. That's what that is. And we can't just say, well, let's just take, 3 days and just show people how to do ROI and then that's it. No, we need to develop algebraic competency and algebraic skills, and that takes time, right? What we should be advocating for is the application. The application should be more geared toward those life skills that you want. All right, let's get into this. This is an equation. Actually, no, I'm wrong. This is an inequality. There's no equal sign. This is an inequality, right? We're going to solve this and graph it on a number line, right? This is an inequality. Now, let's read it first. These symbols right here, these vertical bars, that's an absolute value symbol. That's an absolute value symbol. That means that this expression, when it's all said and done, will be positive, right? So we want to know the absolute value of 10x minus 17, which is really the distance between that value and 0 on the number line, which is why it'll always be positive, because distance is always positive. Plus 2 is greater than 15. So ultimately, we want to solve for x. But when we're dealing with an absolute value inequality, the first thing we got to do is we got to isolate the absolute value by itself on one side of the inequality, right? So here we got an absolute value, and we got this positive 2. So what we got to do is get rid of this positive 2. This positive 2 got to go. Now, how do we get rid of it? The same way we would get rid of it if it was an equation. If it was an equation, we would do the opposite operation. The opposite of adding 2 is subtracting 2, right? So we're going to do this. Minus 2 right here. And then just like an equation, we keep balance. What we do on the left side of the inequality, we do on the right side of the inequality. So if I do minus 2 right here, I do minus 2 over here. Boom. Now, absolute value comes down. Absolute value 10x minus 17 is greater than 13. Don't make a mistake and add that and get 17. Common error. Try not to make that. All right, so now the next thing you do, now that's the first part. We got the absolute value isolated. We got it isolated. All right? We're not done though, of course. Now, how do we solve for x? Now, when we solve for x, we're going to have almost like two answers. We're going to have two answers because we got to now create two inequalities. We got to now create two inequalities. And I hope you're taking notes while you're watching this video, right? That's why it's beneficial that you can pause the video at any point. You got to create two inequalities. Now, to create the first inequality, this is what you got to do. You basically drop this absolute value symbol, and then you rewrite the inequality just as it is. Drop the absolute value symbol and rewrite the inequality just as it is. All right, so it looks like this. 10x minus 17 is greater than 13. Boom. That's going to be one of your inequalities that you're going to use to solve for x, to get one of your answers. Because you're going to have two answers. Two answers, right? All I did, look what I did though. I just dropped the absolute value symbol. Nothing else changed. Not this minus sign, not the 10x, not the 17, not the greater than sign, not the 13. Nothing else changed. For my second answer, I got to do two things. Actually, no. That's a mistake. I got to do three things. I got to drop the absolute value sign. I got to flip the inequality. And I got to make this expression over here its opposite. So I got to do three things. All right? Three things. Make sure you're taking notes on this. So I'm going to have 10x minus 17. This inequality sign, I got to flip it in the other direction. You know what I'm saying? I got to flip it in the other direction. So now I'm doing less than, not greater than no more. Now it's less than. And this 13 is a positive 13. I got to change that to its opposite. Its opposite is negative 13. And now I solve. So I got to solve this, and I got to solve this. I got to solve this, and I got to solve this. That's how I get two separate answers, right? Now, we solve it just like an equation. I'm trying to get x by itself ultimately. So what I'm going to do is I'm going to get rid of this negative 17 first. The opposite of minus 17 is plus 17. So I'm going to add 17. Plus 17 on the left side, plus 17 on the right side. That cancels out. Bring that 10x down. Bring that greater than down. What's 13 plus 17? That's 30, right? So I got 10x is greater than 30. I'm trying to get x by itself. So I got to get rid of that 10. How do I get rid of the 10? I do the opposite of multiplying 10 times x. The opposite of multiplying is division. So I'm going to divide by 10 on the left side, but I also got to divide by 10 on the right side of the inequality. 10, 10, boom, x greater than. What's 30 divided by 10? 30 divided by 10 is 3. So x is greater than 3. That's one of my answers. X is greater than 3, right? But we're not finished yet. We're not finished yet until we solve the other inequality. We got to solve the other inequality. So we follow the same steps. I'm going to get rid of this negative 17. I'm going to add 17 because that's the opposite. And I'm going to add 17. Boom, boom. 17s cancel out. We got 10x less than negative 13 plus 17 is positive 4. Positive 4. We got to make sure we know how to add and subtract positive and negative numbers, right? Now, to get x by itself, I'm going to do the opposite of multiplication because 10x means 10 times x. So we always do the opposite operation when we're trying to get rid of stuff, whether we're solving an equation or an inequality. Whether we're solving an equation or an inequality, some rules are consistent, right? So I'm going to divide this by 10, and I'm going to divide this by 10. Now, be careful. You are not dividing by x. You only divide by what you're trying to get rid of. We ain't trying to get rid of x. We're trying to get x by itself. So we don't divide by x, because if you divide by x, you're going to get rid of it. We're not trying to get rid of x. We want x to chill and be by itself. So we get rid of everything else. So that's why we only divide by 10. A lot of students make that mistake. They want to divide by 10x. Nah, chill. Don't divide by 10x. You only divide by what you're trying to get rid of, right? See, the math should make sense. If you think of this like conceptually, like in terms of a process, like what am I really trying to do here? Then you'll memorize the steps, and then the steps will make sense. I'm trying to get rid of 10. Why am I trying to get rid of 10? I'm trying to get rid of 10 because I'm trying to get x by itself. Why am I trying to get x by itself? Because that's how you solve an inequality, right? Because we want to know what x is less than, right? We don't really care what 10x is less than. We want to know what x is less than. We don't care what 10x minus 17 is less than. We want to know what x is less than. So that's why you get rid of everything else. Divide this by 10, boom, they turn into ones. That's really going to be 1x. 1x and x are the same thing. So then we got x is less than 4/10. Now we always simplify fractions. Right? 4/10 can be simplified. Some people use the term reduce. Reduce, simplify, they're synonymous, right? 4/10, 4 and 10 have a common factor of 2. That means you can divide each of these numbers by 2. 4 divided by 2 is 2. 10 divided by 2 is 5. So that means that x is less than 2/5. So so the solution for this whole inequality, right, is all the values of x that are greater than 3, and also all the values that are less than 2/5. Now, if I graph that, what does it look like? And I'm going to graph it up here. I'm use this space right here. Oh, by the way, follow me on Instagram too, at All This Math. Follow us on Instagram, at All This Math. All right? Since we up here. All right, draw a number line. The number line is just the x-axis from the xy coordinate plane, right? So you draw a number line like this. Draw some vertical lines for your numbers, all right? So what I like to do is I like to look at my boundary points. My boundary points are 3 and 2/5. They are not the solutions. They are not the solutions. Remember, this is not an equation. If this were an equation, x equals 3 would be a solution, but this is not an equation. This says that x is greater than 3. So that means that the solution is all the values that are greater than 3. Any number that's greater than 3. Any number. It don't matter what it is. It's a solution. Also, at the same time, any number that's less than 2/5 is a solution, right? Now, a number that is less than 3 and a number that is greater than 2/5 is not a solution. And we're going to show it visually as an illustration on the number line, right? So let me plot my 3. Let me put my 3 like right here. So that means that's 2, that's 1, that's 0, -1, -2. This is going to be 4, that's going to be 5. So since x is greater than 3, I find 3. Now, question we got to always ask ourselves is, when I draw the circle on 3, should I leave it an open circle or should I shade that circle in? Should I leave it an open circle or should I shade that circle in? Because x is greater than 3 and not equal to 3, we leave it an open circle or a clear circle. It should be a clear circle. So I do this and I leave it. I don't shade nothing in. That circle should not be shaded in, because what that symbolizes is the fact that 3 is not part of the solution set. Every number bigger than 3 is a solution, but 3 is not a solution. Only the number is bigger than 3. So then I got to draw my arrow because x is greater than 3. So then I ask myself, well, where are the numbers that are bigger than 3? Are they to the left or are they to the right? Well, 4 and 5 is right here. I know 4 and 5 is bigger than 3. So all the numbers that are bigger than 3 are to the right. So I do my lines like this. Boom. I go that way, right? Now, that part is done. Now we got to deal with this part. X is less than 2/5. So now you got to ask yourself, and this gives a lot of people trouble. Like they wonder, like, well, it's a fraction, or where is that? Where is it? Is it between 2 and 5, or where is it at? Right? So 2/5. Think about it like this. 2/5 is a fraction, right? So that means 2/5 is less than 1. It's less than 1. But it's more than 0, but it's less than 1. 2/5 is like, like 40 cents on a dollar. 2/5. If you put 2 divided by 5 in a calculator, because that's all a fraction really is, it's just a division problem. That's all it really is. If you did 2 divided by 5 in a calculator, you get 0.4. 0.4 is as a decimal. That's like 40 cents, right? That's more than 0, but less than 1, right? And it's almost halfway, right? But we don't got to be exact. We don't got to be exact. So what we could do is just put a little circle right there, because that's approximately where it would be. That's approximately where 2/5 would be. But this being able to do that really requires you to have a general understanding of fractions, right? You got to have a general understanding of fractions in order to really be able to excel in algebra. You got to understand fractions. You got to go back to those basics. So if you never really learned fractions, you got to do yourself a favor. Go back to them basics and dig in and really learn and study fractions. Practice adding fractions, subtracting fractions, multiplying them, dividing them, reducing them, finding equivalent fractions, comparing values of fractions, doing all those different types of things, right? Do yourself a favor. I'm trying to tell you. All right. So now x is less than 2/5. So then I ask myself, well, where are all the numbers that are less than 2/5? Are they to the right or are they to the left? They are to the left. All the numbers less than are to the left. So I'm going to do an arrow like this. And I'm done. That's my graph. My graph is just like that. All right. So my graph is just like that. Solve it. We solved it like this. This is set notation. Oh, let's do this. Let's put the solution in interval notation. Interval notation. All right. Interval notation. Okay. So x is greater than 3. So the solution goes from 3 to infinity. from 3 to infinity because x is greater than 3. Now, since x is not equal to 3, we're going to use a parentheses. And then I put the 3, and I put the comma. And then I put infinity. But actually, you know what? I'm messing up. Because actually, we're supposed to, when we do interval notation for our solution, we should actually follow the number line. Follow how the number line looks. So hold up. Watch this. Check this out. All right. Let's talk about this first. Because we're going from left to right. Right? If x is also less than 2/5, that means that that interval goes from negative infinity, the smallest number possible, right? Which is really just a concept. Negative infinity all the way to 2/5. All right. So again, when we do interval notation, we're basically modeling or mirroring the number line. So I'm going from negative infinity. And why did I put a parentheses next to the infinity? Because parentheses will always be next to infinity in interval notation. Comma, 2/5. And I put a parentheses on next to that because it's not equal to 2/5. It ain't equal to 2/5. It's only less than 2/5, right? So 2/5 is just a boundary. Now, since we have two intervals, we use this symbol for union, this big U. Boom. That's the union symbol. All right? Like HBCU down in Virginia, Virginia Union University, right? Think of it like that, right? So now I'm going to deal with this. I go from 3 to infinity. So I go 3 to infinity. Boom. I put the parentheses next to 3 because 3 is not included. 3 is only a boundary. I put the parentheses next to infinity because that's just a rule we got to memorize. Parentheses always go in interval notation. Parentheses always go next to infinity, whether it's negative infinity or positive infinity. And that's about it. This is the solution in interval notation, and this is the graph. And we basically done. Not basically done, we are done. Right? That's all to it. All right? So again, if you haven't subscribed to the channel, go ahead and subscribe to the channel. Share the videos. Don't be selfish with the videos. Don't find out about this and then sit there and let it help you with your homework and all that, and then don't tell nobody about it. Don't be like that. Don't be that person. Don't be that person. All right? Share the wealth. Share the knowledge. All right? Help somebody else out. Also, if the video was helpful to you, like the video. Right? Like the video, comment on it, Also, follow us on All This Math. All right? We also got a program on Wednesday nights called Math Related, 8:30. We're trying to make math cool. We're trying to make math relevant. We talking to people that either are mathematicians or math teachers or are involved in works in different walks of life where they utilize math on a daily and a regular basis, So that way we can answer the question, when am I ever going to use this stuff for? So we talk to people every Wednesday night that will let you know different answers to that question of when am I ever going to use this stuff for? A program that I call Math Related. Math Related on Instagram, Wednesday nights, 8:30 p.m. All right? And as always, I say, do remember that there's all this math all around you. Peace.